Hello friends, I am Krishna Kanjani from LJ Institute of Engineering and Technology. Welcome to the online lecture series on kinematics and theory of machine. In this session, we will learn numerical of velocity analysis. Okay, so let's start our session with numericals. So the first numerical, that is, in a 4-bar chain mechanism ABCD, link AD is fixed and dimensions of AB with RPM is given. The length of link CD is given and point D is oscillating about that. Okay, now BC and AD are considered of equal length. Okay, and we have to calculate the angular velocity of link CD when the initial angle is 60 degree. So before starting this numerical, we have to first identify that the relation and how can we calculate the angular velocity. Now to calculate angular velocity omega, we have a relation that linear velocity v is equal to radius into omega. So over here first we have to calculate the linear velocity of that link. Okay, now to calculate the linear velocity, we have learned that the graphical method which is known as a relative velocity method. Okay, so over here we have to calculate the relative velocity of link CD. Now we have learned two fundamental. First fundamental about relative velocity is that a motion of any rigid link having, if we consider point A and B, so in that case the motion of this link AB will be always, if you want to calculate, then it is in a perpendicular direction of line joining these two AB points. Okay, that is the first fundamental we have learned while learning the motion of any link. Okay, so here you have to remember this fundamental to solve or to draw the velocity diagram. Okay, so let's start this example. So first one, we will calculate, we will identify the basic data. So from data, link AD is fixed, that is of 150 mm long. So length of AD is 150 mm, crank AB is 40 mm, link CD is 80 mm, and BC and AD are of equal length. So BC and AD both are of equal length, that is both of 150 mm, and the angle between BAD is given as 60 degree. Okay, so over here first we have to calculate the configuration diagram, that how this system is working. So if we consider this one is your fixation point, then for a simple sketch of 4-bar chain mechanism, link 1, link 2, link 3 and link 4. Over here I can you can choose any dimensions, because if you are randomly choosing, then it may be possible that the dimension may be link A, link B, link C and link D, or it may be of this type of also. Okay, so that dimension will define you that how you will sketch this arrangement. And to sketch this arrangement, first what you have to do, first you have to consider some scale, because over here the dimensions are given in mm. So over here if you consider that you want to sketch this whole diagram, then first you have to refer that the largest dimension and the smallest dimension. Over here the smallest dimension is 40 mm and largest dimension is 150 mm. Okay, so if you sketch a line of 40 mm, then it is the length is 4 cm, then you can sketch it. But the second dimension AD is equal to length having 150 mm, that is 15 cm. Now if you sketch this diagram with the same dimension, then your diagram will appear somewhat like first link is of 4 cm and second of 150 mm. So it is too large to sketch in a simple sketch, in a simple paper. Okay, so now what we will do, we have to consider some scale to draw this arrangement. Okay, so to draw this arrangement, let's consider the scale of this configuration diagram as 1 mm is equal to 2 mm. What it means? That the 1 mm of original dimension is equal to 1 mm of your drawing will represent 2 mm of your original dimension. Okay, so if you consider that you want to draw 40 mm, then what you have to do, simply you have to make half, because 2 mm will represented by 1 mm, so 40 will be represented by 20 mm. So in this way you can calculate all the dimensions. Okay, so over here if you consider, if you want to calculate the length, then AB is equal to 20 mm. Okay, let's make the calculation over here. So let's consider AB is equal to 20 mm and your length of CD will be 40 mm. then length of AD will be of 75 mm and another length AD will be again 75 mm. So these are the dimensions of this body. Now let's start with the fixation, that link AD is fixed and of 150. So AD is, we have to sketch with 75 mm. So we have to first sketch one horizontal line having the dimension of 75 mm. Okay, and this line is defining your link AD. So while you are drawing configuration diagram, you have to always draw with the capital notation. So over here you can say this one is your point A and this one is your point B. Now with reference to this point AD, now let's draw another link. So A is connected with point B, so let's draw link AB, or which is known as a crank AB. So now over here the length of crank AB is 20 mm. Okay, so here 20 mm you can sketch in any of the direction, random direction, but in data it is given with the angle BAD of 60 degree. So BAD, so AD is horizontal, so you have to draw one line which is at angle of 60 degree and will define point B, and this length of this line will be of 20 mm. So over here you can sketch that AD is equal to your 75 mm and AB which is equal to your 20 mm. Now after sketching point B, you have to sketch point C. Now for point C, any angle is not given but dimension is given. Okay, so let's consider the dimension, that the dimension of BC, that is from point B to point C, is given as same as A to D. So BC is similar to AD. So how we can say that BC is equal to, we can say BC length of again same to AD, and how much is your AD? AD is of 150, that you have to sketch with 75. So again here you have BC of length 75 mm. So you have to sketch 75 mm. Now you can sketch this in any of the direction. Let's consider in any random direction. If you have to sketch, then let's consider that BC may be in this direction or in this direction or in this direction. Now another point, that CD. Now again the length of line CD is given, and that is you have to sketch with 40 mm. So over here you can sketch CD line having of 40 mm dimension at any angle. So like in this way, at any angle. Okay, so over here you can conclude that in this system, if you want to sketch this arrangement, then you have to make length of BC as 75 mm and length of CD as 40. So how will you sketch this? So now you can take arc of length BC, because you have to over here you have to use a rounder over here. So if you consider that BC length of 75 mm, so over here you can sketch 75 mm arc radius. So in this radius you can say that point C can belong to any point. Similar way, now you have to calculate or you have to draw an arc of line CD, and this line CD is of length 40 mm. So if you consider that arc of your CD line which is of 40 mm, if you are sketching that, if you are able to get that your arc is sketched over here at any point, so this intersection will give you point C, because if you measure now from this point, then this length CD will be again of 40 and this BC will be of 75 mm. So in this way we can sketch configuration diagram for any of the mechanism, either it is a 4-bar chain mechanism or a single slider mechanism. Okay, so now after sketching this configuration diagram, that is your arrangement of your link, that how your arrangement or how your 4-bar chain mechanism will look. Now you have to calculate velocity. Now to calculate velocity you should have at least certain amount of any velocity, you must have at least velocity of any one link. So over here in this data they have given that crank AB is of 40 mm long and rotates at 120 rpm. So from this we can say that rpm, so if you define rpm with notation n, so n of link AB, or we can say crank AB. Now over here point B is moving and A is fixed, so you have to mention NBA, that is rpm of B with reference to A, and that is given as 120 rpm. So now from n, if you want to calculate omega, that is angular velocity, so omega is equal to 2 pi n by 60. Now in this equation you will put value of n, that is 120 rpm, so you will get angular velocity of 12.568 radian per second. Okay, so that is your angular velocity of link B with reference to point A. Now with the help of this angular velocity you can calculate linear velocity. Okay, so over here in this way we can sketch your configuration diagram. Okay, so in this diagram you can simply refer that how you have considered point A, B, C and D with the dimension of 20, 40, 75 and 75. Now in this diagram, even as the configuration diagram is having scale of 1 mm is equal to 2 mm, so your actual dimensions over here will be of half, that is of 20, 75, again 40 over here and 75 over here. But you have to mention it as the original dimension because you have mentioned your scale in this numerical. Now velocity. So with the help of angular velocity you can calculate linear velocity. That linear velocity we have learned V is equal to R into omega. Over here R is the radius, so radius of your link AB can be considered as capital AB. So we can say omega into AB. Now omega is 12.568 radian. So 12.568 radian into your length AB. Now here the length is given in unit mm. Now to calculate velocity we will always consider velocity in the unit of meter per second. So to calculate in meter per second you have to convert the dimension in mm. So here it will be 0.05 meter. Okay, so 0.04 into this will give you the velocity, linear velocity of point B, that is equal to 0.503 meter per second. Okay, so this is the procedure to sketch configuration diagram for this mechanism. So with following this procedure you will be able to draw the configuration diagram. Now let's sketch velocity diagram. So over here to calculate velocity diagram you have to take velocity of any one link. So over here the velocity of link BA is given. So we can say that velocity of BA, that is velocity of B with reference to point A. So now for rigid link velocity will be always perpendicular to the line joining these 2 points. So over here the perpendicular line, if you want to sketch then you can sketch in 2 directions, either in downward direction, either in upward direction. Okay, over here you can sketch in any of the direction but now if you refer the data then RPM 120 RPM is given in clockwise direction. So you have to consider that your link is rotating in clockwise direction. So the velocity will be always in only downward direction. So from that you can simply say that now in this case your velocity will be always in downward direction. Okay, so if you randomly or arbitrarily choose first fixation point, fixed point A, because A point is not moving or D point is not moving, so you can arbitrarily choose this A point and D point both as the same, and at any point if you consider this one as point A, and similarly you have to consider point D at the same point, because both are defining your fixed point. And over here in this mechanism your fixed point or fixed link is your AD link. Over here your AD link is fixation, that's why A and D both the points will be represented at a single point. Now with reference to point A, B is moving in downward direction. So if you want to sketch the velocity diagram then over here you have to consider that velocity of B with reference to A will be in downward direction. Okay, so this is the direction of A to B. But now what will be the magnitude? Okay, so over here velocity is given as 0.503 meter per second. Now here the velocity is in meter per second. So again we have to consider some scale. If you will not consider any scale then how will you sketch? So over here let's assume that for this mechanism velocity diagram for scale for velocity diagram is 1 meter per second is equal to 100 mm. Okay, so let's consider it once again. So if you will consider that the scale of this mechanism is 100 mm, so 1 meter per second velocity can be represented by 100 mm. So over here velocity of B that is 0.503 meter per second. So we can represent it with the length AB is equal to 50, because how will you get this value? So here you can say that 0.503, if you multiply this value with your scale, that is your of 100 mm. So 0.503 into 100, that is 50.3. So you can say that length of line AB is equal to 50.3. Okay, so now with the help of that calculation, let's consider that again. If you consider fixation point, that is your over here, if you consider the velocity of A point with reference to B, then it will be in this downward direction and with the magnitude of 50 mm. So you have to sketch one line of 50.3 mm, or you can say 50 mm, and this line is defining your points, that is your fixation point A to point B. Now as we have referred that point A and point D are belonging to same point because both are fixed point, so we can say that A and D both are represented at this starting point. Okay, now second link, that is your link BC. Now velocity of link BC will be again perpendicular to this line. So over here if you want to sketch that velocity of point B, BC must pass through either point B and either point C. Okay, simply we can say that if you have to sketch velocity of link BC, then it will be perpendicular to this line BC and it must pass from point B and point C. So over here in this velocity diagram, if you consider the point over here, then this line which is velocity of point BC must pass through this line, or we can say from this point. Either it will be in upward or in a downward motion. Okay, now fourth link, that is your link number 4, CD link. Now velocity of CD will be again perpendicular to this line. Okay, so over here velocity of CD will be perpendicular. Now it must pass from either C or D. Now in this velocity diagram you have point A and point D. So this point D, if you want to sketch velocity of link CD, then it must pass from point D. So over here you have to sketch in such a way that this horizontal, somewhat like a line which is perpendicular to CD, must sketch in this way. So over here this one is representing point D and this intersection will represent point C. Okay, so from this sketch, now if I am correcting or if I am finalizing the points, so now from this diagram, now initially you have to sketch this line with the rough hand, or you can say you can use dash lines over here also. Okay, so now if you will join this point B and C, then this BC line is representing velocity of C with reference to B, and similar way this CD line is representing velocity of C with reference to point D. Okay, now how you can sketch this? So the same diagram will somewhat look like this if you are drawing it with perfect measurements. Then over here the line AB 50.3, so over here from point A to point B, that is you have initially calculated 50 mm, then perpendicular to this line BC and CD. So again from BC and CD you will get the velocity diagram for this 4-bar mechanism. Now after getting this diagram, now you have to simply measure this value. Okay, so now in this numerical we have to calculate angular velocity of link CD, that is omega CD. Now to calculate omega CD, we have to simply use relation that V of CD is equal to R into omega of CD. So first what we need velocity of CD. So velocity of point C with reference to point D. How we can measure? So you have to measure this length. This is representing length. This length is representing velocity of CD. Okay. So if you have to, if you consider that the length CD is equal to 38.5, then this vector CD is equal to 38.5 into your scale, so that will give you 0.385 meter per second velocity of link C with reference to point D. Now to calculate angular velocity, so over here we can say V is equal to R into omega, or we can say omega is equal to V by R. So over here V is equal to VCD upon length CD. VCD is 0.385, and over here the length CD, length of link CD, which is given as 80 mm. So over here it is 0.08 mm. Now over here you must consider one thing, that the length we have sketched will be of 40 mm only, because it is represented with this scale, but the actual measurement is considered as a 80. So over here you have to consider 80 mm, and the length, the velocity is in meter per second. So over here the length will be in meter, that's why you have to consider 0.08 meter. Okay, so with this calculation you will get the angular velocity of 4.8 radian per second, and which will be moving in a clockwise direction. Okay, so in this way we can we can solve the numericals with the help of relative velocity method.